Hello guys, I'm here again, Engineer Jewel Ryan Nicole D. Riosa, and I will be discussing today applications of algebra. So, our main goal for today is to solve worded problems. I will be showing you how to solve worded problems, and then, of course, I will be giving you steps or suggestions on how to solve these problems. So, first of all, I want to introduce to you mathematical language because this is the language that we will be using throughout this worded problem application of algebra. So, first I want to define what language is. Language is the system of words, signs, and symbols which people use to express ideas, thoughts, and feelings. And then it is a systematic means of communicating ideas or feelings by the use of conventional signs, gestures, or marks having understood meanings, most especially in this pandemic, no? We realize a lot of things. We don't usually express our feelings in different language that we know, maybe it in words or in actions, but it is really important to show affection nowadays. And then language, so let's go back to the topic. So language is how you communicate to others. And then mathematical language. So this is the language that we will be using here in solving worded problems. So what is mathematical language? As seen here, it is the system used to communicate mathematical ideas. So since it is mathematical language, we are specifically pointing out or giving emphasis to mathematical ideas. So it has its own grammar. It has its own syntax, symbols, vocabulary. So we will be having different terms here. So I hope you can be familiar with it because we will be using it many times, especially as engineers, as architects, or those who have many math subjects because math is everywhere. Mathematics has certain language features unparalleled in other languages such as representation. So mathematical language is a different language, and as a math lover myself, I really enjoy the mathematical language. And then of course, next slide. So here are the characteristics of mathematical language. The use of language in mathematics differs from the language of ordinary speech in three important ways. So why they differ kaya? So first, mathematical language is non-temporal. There is no past, present, or future in mathematics. Unlike in English, we have called the past tense, present tense, future tense, past participle, like that. In mathematical language, we have no past, no present, or no future. So, another characteristic, mathematical language is devoid of emotional content. So, as I have said earlier, language is a way of communication or way of expressing your thoughts, your feelings. But then, mathematical language is devoid of emotional content. Lastly, mathematical language is precise. So, in mathematics, we are precise. We are accurate. So, we have here the basic operation terms and symbols. So, this is part of the language, the symbols and terms. So, I know you are familiar with this, addition. So, this can be usually termed also as plus, the sum of increased by, total, and then for subtraction, minus, the difference of, subtracted from, decreased by. For multiplication, we have multiplied by, the product of, times of. And then for division, we have divided by, the quotient of, or per. Now that you know the basic terms of operations and symbols in mathematics, so let's proceed with mathematical expression. In this example, we have 3x squared plus 7x, in which 3x squared and 7x is separated or enjoined with a plus sign. That's why it is called a mathematical expression. So we have two terms, the 3x squared and 7x. So obviously, the terms are separated from other terms. To call it a mathematical expression in general, it can either be separated by symbols of plus, minus, multiply, or the other terms discussed earlier, the other symbols that I mentioned. A single term also may contain an expression in parentheses or other grouping symbols. So take note of that. So let's go here with mathematical sentence. This is defined as, this combines two mathematical expressions using a comparison operator. So these expressions either use numbers, variables, or both, as long as it has a comparison operator. The comparison operator includes equal, not equal, greater than or equal to, less than, and less than or equal to. And then the signs which convey equality or inequality are also called relation symbols. So we termed it also as relation symbols because they specify how two expressions are related, or they give emphasis on the relation, or they give highlight on the relationship of the expressions, of two major expressions. Again, a mathematical expressions also containing the equal sign is called an equation. If from the word itself equal, equate, equation. The two parts of an equation are called members. So we have two parts. A mathematical expression containing the inequality sign is called an inequality. So if it has equal sign, it is called equation. And then if it has an inequality sign, it is called an inequality. For illustration purposes, this is an example of an equation, primarily because it has an equal sign. And of course, if we have an equal sign, as I have mentioned in our previous slides, it is called an equation. In such a case that this uses an inequality sign, then this will be an inequality. So let's go now to our next topic, translating English into math language. So I mentioned earlier that there is actually a big difference between English language and math language. So in math language, we'll be using different kind of symbols, and English, it's mostly pure words. So here I will be giving an example on how to translate English language into math language. So for example, we have here 6 less than twice a number is 45. So it is composed purely of word, a sentence. And then so we have the solution here. Step 1. Let x be the number. So, usually, lagi nyong makikita, we'll be utilizing x as the variable, but it is not necessarily limited to x. You can use the alphabet A, B, C, up to Z, but x is the most commonly used. So, it is up to you. You just have to indicate, for example, let J be the number. You just have to indicate what variable are you using. So next, so we have x being the number, and then twice means 2 times, and then so twice a number will be 2x. So we have x the number, twice the number is 2x. And then next, less than means minus or subtracted by. So 6 less than is negative 6 or minus 6 subtracted by 6. 4 meaning, so 6 less than twice a number is 2x, that is twice a number. And then 6 less than minus 6. So 2x minus 6 is equal to 45. But then again, this is not our final answer because we have a symbol for equal. So our final answer is 2x minus 6 is equal to 45. So it is a must to have proper representation and to read the problem one by one, and then check the answer. 2x minus 6 is equal to 45. So 6 less than twice a number, which is 2x, and then 6 less minus 6 is 45. So that is 2x minus 6 must be equal to 45. So, before proceeding to actual problem solvings involving fraction, age problems, integer problems, I will be giving another example on translating English into math language. So, the example goes like this. 9 greater than the quotient of a number and 7 is 11. Again, 9 greater than the quotient of a number and 7 is 11. So again, for the first part of the solution, have a proper representation. For example, let x be the number, but you can also let j be the number. That's my favorite letter because my name is Jewel. If your favorite letter is M, so let M be the number. As long as your representation is right, it's okay. So again, you have to read or comprehend the example. So first, quotient means divided by. So quotient of a number and 7 will be x over 7. So in my case, if I want to use j, the quotient of the number j and 7 is j over 7. So next statement. Greater than means plus. So there's expression here, or our example says greater than 9. So in symbol, that will be plus 9. And lastly, 9 greater than the quotient of a number and 7 is equal to x over 7 plus 9. So here we have x over 7 plus 9, but that the quotient of a number and 7 plus 9 is equal to 11. So we have here x plus 7, x over 7, plus 9 is equal to 11. So check it. 9 greater than the quotient of a number. Our number is x over 7 because quotient of a number is 7. Plus 9 is 11. So x over 7 plus 9 is equal to 11. So let's go to the next. So here we have an example for solving word problems involving fractions. So the example goes like this. 3/5 or 3 over 5 of a group of children were girls. So as you can see in our picture, if as a tip, if the illustration is not provided, it is highly recommended to construct your own drawing of the problem because it really helped you a lot. So 3 over 5 of a group of children were girls. So we have here 5 parts, and 3 of that 5 parts were girls. And if there were 24 girls, how many children were there in the group? So we have 3 over 5 of the children were girls, and that we have 24 girls. So meaning, for the 3 units in our 5 parts, or in our total of 5 units, that 3 units belong to 24 girls. So if 3 units is equal to 24 girls, we have 1 unit is equal to 8 girls, right? But then we have 5 units. So meaning, if we have 5 units and 1 unit is equal to 8 girls or 8 children, meaning 5 units times 8 children is equal to 40. Therefore, our conclusion is there were 40 children in the group. Thank you. So let's proceed to the next problem. The next problem is all about integers. So our problems goes like this. Find two consecutive integers whose sum is equal to 129. So solution, of course, we have to have proper representation. And again, we'll be using x because this is the most commonly used variable. But again, as I am always saying, you can always use any variable available as long as you know what you are doing. So let x be the first number. And then we have let x plus 1 be the second number. Why it is x plus 1? Because it is stated in the problem that consecutive integers. So if we have x as the first number, its consecutive integer or the integer consecutive to it is x plus 1. Next, so use the fact that their sum is equal to 129. So we have to write the equation, then simply find the value of x. So our learning about translating English to mathematical language will be really helpful in this problem. So x, our first number, plus our consecutive number, x plus 1, is equal to the sum, which is 129. So again, x plus 1 is equal to 129. Again, solving this simultaneously, 2x plus 1 is equal to 129. Transpose 1 to the other side. So 2x is equal to 128. Divide both sides by 2 to get the x. X will be 64. But then the question is, find two consecutive integers. X being 64, we have only the first number, but then we are also looking for the consecutive number, that is the x plus 1. So our final answers are 64 and 65. 64 and 65. We can also check our answer. So two consecutive integers, 64 and 65. That's right, that's consecutive. But then let's check if the sum is 125. 129. So 64 plus 65 is equal to 129. So our answer is correct. It is highly recommended to check your answers. Solving problems like this, I think this is the most difficult, most challenging. But then I love solving this because now I discovered this table method in solving age problems. And I think this is one of the most comprehensive method of solving this. And that's what I am sharing with you today. So the example is, John is twice as old as his friend Peter. Peter is 5 years older than Alice. In 5 years, John will be 3 times as old as Alice. How old is Peter now? So, first tip, read again. John is twice as old as his friend Peter. Peter is 5 years older than Alice. In 5 years, John will be 3 times as old as Alice. How old is Peter now? So, step 1, set up a table. This is what I am talking about. And then we have here age now. You can put here present age or age in 5 years or the future age. And then put the names of the cast who are John, Peter, and Alice. So step 2, of course, fill up the table with information given in the question. So it is a must to read and read and read the question again. So John is twice as old as his friend Peter. And of course, you should pick a person which is a proper representation of an age. For example, my x here is Peter. Or you can use any other variable again for if you want to use M or A or P for Peter. So the age of Peter is X. And then first statement, John is twice as old as his friend Peter. So meaning, if Peter is X of age, meaning John is twice of Peter, meaning that is 2x. Okay, we have the age of Peter, which is 2x. So Peter is 5 years older than Alice. So if Peter is X years old, Alice is X minus 5 years old, since Peter is older than Alice. So we have completely discussed the age or the present age, the age now. But then, there is another statement. In 5 years, so in the future, in 5 years, John will be 3 times as old as Alice. Oh my God. So, in 5 years now, so we have here, the age of John now is 2x. So, meaning, his age in 5 years is 2x plus 5. So, if the age of Peter now is x, his age in 5 years is x plus 5. If the age of Alice now is x minus 5, her age in 5 years will be x minus 5 plus 5. So we have here a complete table. So what are we going to do with the table? So here's what we're going to do. Write the new relationship in an equation using the ages in 5 years. So in 5 years, John will be 3 times as old as Alice. It's according to our problem. So meaning 2x plus 5, that is the age of John in 5 years, is equal to 3 times as old as Alice. So meaning the age of Alice in 5 years, that is x minus 5 plus 5 multiplied by 3. So we have our equation now. We can solve for x. So 2x plus 5 is equal to 3x. And then 3 transpose 2x to the other side. 3x minus 2x is equal to 5. So we have x is equal to 5. So we have x is equal to 5 and x is Peter. We have Peter is now 5 years old. So I hope the table method really help you in solving problems. But then I will be giving you another example using this table. So let's proceed now. So here's another example of age problem utilizing the tables. So John's father is 5 times older than John. And John is twice as old as his sister, Alice. So it's always John and Alice. In 2 years' time, the sum of their ages will be 58. How old is John now? So again, I recommend to read it again. And then first step, set up a table. So we have the cast, John's father, John and Alice, and then the present age and the future age, which is age in 2 years, according to this problem. So fill up the table. So in this case, we represent the x age to John. So if x age is John, and then John's father is 5 times older than John. So the father's age is 5x. And then John is twice older, and John is twice as old as his sister Alice. So this is quite confusing, right? Because John is equal to x. And then John is twice as old as his sister Alice. So you should be careful in reading and representing equations, especially in age. So it's John is twice as old as his sister Alice. So meaning Alice is 1/2 the age of John. Because if you multiply Alice's age by 2, it should be John's age. That is why we have the present age as 1/2 x. Okay? And then in 2 years time, so we have age in 2 years, another table for that. The sum of their ages will be 58. But the question is, how old is John now? So if how to fill up the future ages? If father of John is 5x, so his age in 2 years is 5x plus 2. If the age of John is x, in 2 years that will be x plus 2. If Alice's age is half of John this year or in present, in 2 years, that will be 1/2 x plus 2. So again, writing the relationship because it is stated in the problem that the sum of their ages is 58. We have 5x plus 2, that is for father. And then we have x plus 2, that is for John. And then we have 1/2 x plus 2, that is for Alice. And the total of their ages is 58. So we combine all the variables with all of the variables and then the constant on the other side. 5x plus 1/2 x, that is 6.5 x, which is equal to 58 minus 2 minus 2 minus 2, that is 52. So 6.5x is equal to 52, that is equal to x is equal to 8. So John, as our x age, that is now 8 years old. So one recommendation also is to keep on solving problems. And if you have questions, you can always message me and I will try my best to help as early as I can reply on you. So that's all for today. If you wish to have a copy of this PowerPoint presentation, again, if you also have questions regarding the topic, kindly email me at ryannicole05@gmail.com. Please don't forget to subscribe. Thank you.